Hello. Today we're going to be talking about zones. Zones are also referred to with terms such as approximation and continuous motion. So we're going to examine a motion line of code here, and we're going to talk about the Z that we see there, the zone, what it represents, what it does, and the pros and cons of it. It does two things to begin with. The first thing is it puts a spear or a circle around the point basically, and this will make sense in a minute, with a radius specified by the distance I specify in the line of code. In the case of what we see here, I have a Z of 50 or a zone of 50. So I'm creating an approximation zone or range with a radius of 50 millimeters. Now this does two things. It gives the robot the ability to sort of cut the corner there, to bypass, in this case, P10 by a little bit. And it also gives the robot the ability to read ahead. But not only does the robot read ahead, it's able to execute up to 3 steps ahead of time. So let's look at this a little closer. If we look at these 3 lines of code here, we see that the first 2 are identical, with the exception that we have a Z50 and the word fine here. So let's look at this code. We have a move J, a joint interpolated move, or our speed move, our fast move. A move J to P20. So it's going from wherever it was at to P20. But we have a zone of 50 around P20. So by putting a zone in my line of code, I'm giving the robot permission to leave the program path. But what this zone does, what it exactly does, is create a approximation range or an approximation zone around P20 with P20 directly in the middle. Now everywhere around P20 in this zone will have a radius of 50 millimeters. I'm giving the robot permission to, once it crosses into the approximation zone, to veer off of the program path and return to the program path once it leaves the approximation zone. So this gives me the ability to cut the corner here. So as we left this point, the robot's reading this line of code. It sees a zone of 50. It knows to bypass P20 by 50 millimeters. And once it bypasses P20 by up to 50 millimeters here, it will be, once it leaves the approximation zone, it will be back on the program path. And it will remain on the program path until it reaches, in this case, P30. But P30 is also a zoned move or approximated. This is what we call approximation or continuous motion. It enables the robot to continuously move without ever having to use its brakes and come to a complete stop. Now if I need the robot in this case to come to a complete stop at P20, if I need it to hit P20, then I'm going to have to put in what's called a fine move. A fine move stops the continuous motion because the robot will speed up, it will reach its constant or maximum velocity there, and then it will slow down and stop at P20. Now this stop is a very brief pause. It's not even noticeable really to the human eye. It looks more like a jerking motion. But the robot will go exactly to P20 with a fine move. Now there are also little tricks that are used by programmers every now and again, such as a zone of 0 or a zone of 1 to get it really close to that point without ever actually stopping. Now as we see, we got a zone of 50 here and a zone of 30 here. And even though I have a zone of 50, I don't actually miss P20 by 50 millimeters. That all depends on your approach and your exit angle. Here we have an acute angle, so we're going to miss the point by a pretty good distance. But here we have an obtuse angle, so we're going to miss the point by a much smaller distance. So the zones, by incorporating zones into our line of code, it gives us the ability to give the robot the opportunity or the permission to cut corners and to maintain its continuous motion so that it doesn't have to brake and it doesn't have to stop. So let's look at some more examples. On the next example here, we can see the advanced run, also known as the advanced read. What we're doing is giving the robot permission to activate or use the advanced run. And with the advanced run on, the controller can read and execute up to 3 steps ahead of time, depending on processor speed and load, processor load. Now that can be good or that can be bad. Not only does it read 3 steps ahead of time, it executes 3 steps ahead of time. So as we see here, when we have all zoned moves, the robot has to be able to read ahead. And the reason it has to be able to read ahead, because when it's on its way to P10 here, it knows it's going to approximate P10 on the approach side by up to 100 millimeters. But it also knows, since this is an approximate positioning, it's going to bypass P10 in this case and head off towards P20. So it has to be able to read ahead to calculate the path planning data to get to P20. Otherwise, it would have to come to a complete stop. So here we have zones of 100. So our robot's making a move J, a joint interpolated move to P10, and as it's on its way to P10, it reads that it's a zone. Then, still on its way to P10, it reads ahead and calculates the motion it needs to get to the next point. So it's already figured out its approximation motion here. So it's probably still on its way to P10, maybe very close to approaching it. Now it's reading ahead to P30 because it has to know how to bypass and leave the approximation zone here for P20 and head off towards P30. So as it reads and calculates the data for P30, then it reads and executes the next line of code. In this case happens to be set output 1. So as the robot approaches, in this case probably P20, it's switching output 1 to the state of high. Set output 1 is a switching function. Actually, the set part of it is a switching function. Output 1 just simply happens to be the name of the output that we're turning on here. So in this case, by using all zones, I have actually turned output 1 on up to 2 to 3 steps ahead of time, depending on the processor load. Now that can be okay in some circumstances, but some circumstances maybe not. If output 1 operated my tool, if it was a gripper control, a weld gun control, a paint sprayer, well, I'm closing my gripper, spraying paint, or trying to weld 2 or 3 steps ahead of time. So that's probably not a good thing. In a case like that, I'm going to have to change the zone to a fine move. By changing this zone to a fine move, even though the moves above it are all zoned, the robot's approaching P10, it sees it's a zone, so it knows it has to read ahead past that to calculate its path from P10 to the next point. So it reads ahead, it reads P20, it calculates the path planning data to P20 and then how to leave P20 to head off towards P30. But as it reads the line of code P30, it sees the word fine. So it knows that P30 is now in exact position. So at this point, the robot stops reading ahead, and it does not read another line of code until the robot physically reaches P30. Once the robot physically reaches P30, it then reads and executes the next line of code. So in the case of operating our tool, I probably want to operate my tool after a fine move. And also, just so you know, a wait time always stops the advanced run. Not a wait, DI, or a wait until, but a wait time. So let's look at some of the effects of the advanced run and continuous motion. Here we see 3 different motions, P10, P20, and P30, with fine positioning. So let's go over this really briefly. And what we got here, the CV stands for when it reaches continuous velocity here. DACC is for deacceleration. P20, continuous velocity, deacceleration. P30, excuse me. So we leave P20, the robot accelerates, it hits constant or maximum velocity. Then it has to decelerate and come to a complete stop at P20. Then it reaccelerates, hits constant velocity, deaccelerates, and comes to a complete stop at P30. So you can see with 3 moves we have 1, 2 acceleration phases, 1, 2 deceleration phases, and only 2 maximum velocity phases, and 3 complete stops. So let's look at this same set of 3 motions with continuous motion. Next we see the same series, P10, P20, and P30, but look at the benefits of continuous motion as far as cycle time goes. We accelerate, and once we reach our constant velocity, the robot's just continuously going by P20, and then it has to stop at the end of the program here at P30. So just by making this one move continuous here, we have cut out a complete deceleration phase, a complete reacceleration phase, and a complete stop. So zones have their benefits, but they also have their disadvantages, and you want to be very careful when using them, because if used improperly and I don't pay attention to my zones, I can make a tool or other devices actuate or operate early, which can cause a lot of damage to devices in the cell and to people possibly. So let's look at the line of code here, and as we see this small little program I've got put together, it's a joint move here to P10 with a zone of 50, a joint move to P20 with a zone of 50, a joint move to P30 with a zone of 50. Now I see I'm setting an output, and set always turns an output on, so I'm setting output 1 high here. I'm turning it on, switching it on. Now, if I needed to change this zone of 50 to a fine move, all I have to do is double tap the Z. Double tap Z50, and I come to my argument screen here. And if I go all the way up, I'll see the word fine. Once I select fine, put it in my line of code, problem solved. The robot will go to P10, P20, read the line of code P30, will not read past that line of code until it reaches P30. Once it's reached P30, it will then read the next line of code, and in this case, set output 1 or switch it on, and then finish the rest of the program. So I hope that helps you understand zones a little better, and stay tuned for some more videos coming up. We're going to be covering the entire lines of code, and we're going to get into tools, work objects, and our quick set menu, such as that here, and also our ABB main menu. So we're going to be covering a lot of information, and hope it helps you guys out, and good night, and everyone have a good evening.